Hello everyone, this is the first lesson recording for IM1, February 9th, 2021. Let's begin with some announcements. We're going to have Unit 4 test next class. It's going to include some reviews from solving one variable equations and graph of linear equations. Please review those topics, as well as the new topics, square root, cube roots, and arithmetic and geometric sequences and systems of equation. You'll be provided with a review packet towards the end of the class that you will be working on, and it will also be part of your homework. Okay, goal for the day. We are going to be solving system of equations, making connections, and review for unit tests. So let's first consider if you have this system of equations. Okay, remember when you have multiple equations, that's a system of equations, and if you're looking for a solution that satisfies both the equations. Now if you are asked, is 2, 5 a solution to the system below? What is the question really asking? Okay, and is it? Okay, I want you to tell me in private chat, is this the solution to the system? How do you check? Okay, is it yes or is it no? Okay, I would like you to try to do it yourself and then come up with an answer. And remember, when you see the notation with two numbers separated by comma and in parentheses, that means the very first value you're referring to is the x value, the second value is the y value. This is different to just if you wrote 2, 5, it's just two separate numbers. It does not mean the first number is x value, second number is y value. However, when you have the parentheses, that's what it means. So do not write it like this. Okay, so it's asking when the x value is 2 and y value is 5, does the equation, are both the equations satisfied? How do you know? Well, here's the question again. And Kin and Malik approached the problem two different ways. They both got no as their answer. But what's the difference in their approach? Let's look at that different approach. What Kin did was he noticed that, okay, the equation is, the y is isolated, the variable y is isolated for both equations, so he used equal value method to solve the equations and come up with the value of x and the value of y to be x is equal to 2, y is equal to -7. Okay, so what did Malik do? He did not go through the whole solving process himself. He said that, oh, we're just being asked if 2, 5 satisfies the first equation and does it satisfy the second equation. So he started by plugging in the value of x. Remember, x value is 2, y value is 5. So whenever he saw the first equation, y value, he wrote 5 there. When he saw x, he wrote 2. So 5 is equal to 6, in parentheses 2 minus 19. And the question is that equal? Well, he started simplifying. 6 times 2 is 12. 12 minus 19 is -7. -7 is never equal to 5, right? So he knew that 2, 5 does not satisfy the first equation. Well, if he does not satisfy the first equation, then it's not going to satisfy both the equations, right? It failed with the first equation. If you pass with the first equation, yes, then you would need to check the second equation to see that it passes both the equation. Okay, so if you're given a possible solution, we can test it and see if it makes the system work. Malik's method is much easier than Kin's method. Certainly, if you're just asked, is some x and y value a solution to the system, Malik's method is much better. If you are asked to solve for the system of equation, yeah, you do need to go through Kin's method. But this is not what's being asked, so Kin's method is probably not as necessary. So at this point, I would like you to take notes on this. So we are being asked, is x is equal to 2, y is equal to 7, the solution to the system below. Okay, we need to check both the equations. So let's start with the first equation. Y is equal to 8x minus 9. Okay, I know that y value is 7, so I'm going to substitute 7. X value is 2, so 8 times 2, and I am using parentheses, minus 9 as a placeholder. Okay, I know between 8 and x is multiplication just the same way. 8 and parentheses 2 means it's multiplication. 8 times 2 is 16 minus 9. 16 minus 9 is 7. Okay, and that does check out, doesn't it? Okay, so that was the question and it checks out. So I know that the first equation is satisfied. Okay, now we need to check the second equation. The second equation says y is equal to negative 3x plus 13. I know the y value is 7, so 7 written here, and x value is 2, so negative 3 times 2 plus 7, 13. Is this true? Does this equation work, or is the equation satisfied with these values? Well, the left hand side is already simplified, so we just need to simplify the right hand side. Negative 3 times 2 is negative 6 plus 13 is again 7. So 7 is equal to 7, so that checks out. That means the second equation is satisfied. So since I know that 2x is equal to 2 and y is equal to 7 satisfies both of these equations, okay, it's not enough that it satisfies one, it needs to satisfy both equations. I know that 2, 7 is a solution. That's my conclusion from it. Okay, now let's extend the solve using substitution to level 2. Okay, what if you have a system of equation looking like this? X minus y is equal to 5 and negative x plus 3y is equal to 1. Well, what's wrong with this? Can we solve it with the skills that we have? We don't have the variable isolator. Remember, we want at least one of the equation to be x is equal to or y is equal to, so that we can use the substitution method. We don't know what to substitute as it is, right? And we're thinking, oh no, what do I do? Is there a way? Okay, can you think of a way we can use, you can solve this? Please enter your strategy in the chat. And yes, there is a way. Okay, we don't have one of the x's or y's isolated as we need here, but can we do that? Okay, we can choose one of the equation and change the equation so that we do have x is equal to or y is equal to. To do that, I'm going to pick the very first equation. So I have currently x minus y is equal to 5. Okay, remember how we changed the equation in standard form to slope-intercept form, or slope-intercept form to standard form and so on, where we just move the variables around. Okay, so remember, we just want either x is equal to or y is equal to by itself. Say if we just wanted x is equal to by itself, then what is it that we don't want? We just don't want this negative y. Okay, we don't want this negative y. How do I get rid of this negative y? I can add y to both sides of the equal sign. Okay, because negative y plus y, it's just like adding or subtracting numbers. You know, when you add or subtract a variable, it becomes 0. So you're left with x plus 0. I don't even have to write that. Is equal to, on the right hand side I have y plus 5, or 5 plus y. It does not matter. Okay, so now I have one of the equations isolated, and these are equivalent equations. Okay, they're same equation, they're just slightly different looking. Okay, they're same equations. So now I know how to substitute this x is equal to y plus 5 into the second equation. So whenever I see an x in the second equation, I am going to put y plus 5. But remember, this is negative x, so I am going to put negative, and then in parentheses, whatever x is, which is y plus 5. And then write the rest of the equation is 3y is equal to 1. Okay, this negative parenthesis means negative 1 is being multiplied to each of the terms, which of the numbers and variable inside. So negative 1 multiplied by y is negative y. Negative 1 multiplied by 5 is negative 5. Plus 3y is equal to 1. And then from here, I see that the like terms are my negative y and positive 3y. So negative y plus 3y is 2y, because negative 1 plus 3 is positive 2. And then we still have negative 5 on that side is equal to 1. From here, I can solve this two-step equation. Okay, we add or subtract before multiply or divide when we are solving. Remember, we go backwards, so we need to get rid of this negative 5 by adding 5 to both sides. And that becomes my 0. And so you're left with 2y is equal to 1 plus 5 is 6. And then from here, I am going to divide both sides by 2 because 2 is being multiplied to y. So then y is equal to 3. Okay, now that I've found my y to be 3, I still need to find my x value. Okay, so for the x value, I am going to go back to the equation that I've said. It's x is equal to y plus 5. So instead of y, I am going to put 3 plus 5, because that's the value of y I just found, and that comes to 8. So I have just found my y value to be 8 and x value to be 3. And so that's how you would solve this system of equation when neither of the equations are isolated. You just manipulate, you change the equation with all the legal moves that we're allowed to do in algebra, so that you do isolate one of the equation to be x is equal to or y is equal to, and then substitute into the other equation. Okay, so I would like you to take notes now. Okay, so I'm going to go through the process again using a different example. If you have 2x plus y is equal to negative 1 and negative 2x plus 4y is equal to negative 24, remember, neither of the equation is isolated for either x or y. You don't have x is equal to or y is equal to something in either of the equations. So what do? Well, you look at, you call the first equation equation 1 and the second equation equation 2. Alright, so which equation lets you easily isolate x or y? What do you think? Looking at both the equations, which one would be easier to convert to y is equal to or x is equal to? Maybe x is equal to, maybe it's y equals to. Okay, so then rewrite the chosen equation to isolate the variable. And then the final step is to solve using substitution method again. So looking at this, I'm going to choose the first one because why? I see that y is already there. The only thing I need to do is get rid of this 2x, and that's what I do here. And so then I come up with y is equal to negative 2x minus 11. So this is a new equation, so we call this equation 3, but this is really equivalent to the equation 1. So this is same as equation 1, it just looks slightly different. It's the same equation, just a different version of it. Okay, so now solving equation 3 and equation 2 is like solving equation 1 and 2. Then you solve the equation using the equation number 3 and equation number 2. And I won't go through that, but you know how to solve using the substitution method.